Hi everyone. Today we are going to explore the Regula-Falsi method, also known as the method of false position, to find the zero of a continuous function. This method is closely related to our previous bisection method as both rely on the intermediate value theorem as their underlying principle. Let us quickly recall the intermediate value theorem. If f of x is continuous in a closed interval ab and if f of a times f of b is less than 0, then there exists at least one real number xi between a and b such that f of psi equal to 0. In the bisection method, we repeatedly bisect the interval ab, ensuring that the root always lies within one of the subintervals. The Regula-Falsi method also partitions the interval into two parts, but the way we choose the next partition is different here. Instead of simply bisecting, we use a secant line to estimate a better approximation of the root. This gives us a false or approximate position of the root, which brings us closer to the actual solution more efficiently in many cases. Before discussing the general procedure, let us first understand the method of false position through an example. Let us find a real root of the equation x cube minus 2x minus 5 equal to 0. Let us start by drawing the graph of the function x cube minus 2x minus 5 equal to 0. So one can see that the graph cuts the x-axis. That means it has a real root. So let us try to find the root in Regula-Falsi method step by step. We can see that the function takes the value minus 6 and 16 at 1 and 3 respectively. The values are of opposite sign, that means the root lies between 1 and 3. So as we told earlier, our next task is to draw a secant line joining AB and find its intersection with x-axis. So we can see that the secant line intersect the x-axis at 1.54550. So x equal to 1.5455 is actually a value between 1 and 3. Now we are going to take this as the false position or approximate root. Let us calculate the values of the function at 1.5455. Then we get that value as negative. Then f of 1.5455 is negative and f of 3 is positive. That means the root lies between 1.5455 and 3. Now, in the next step, we will try to find the secant line joining D and B, where D is the value of the function at 1.5455. That means coordinates of D are 1.5455 minus 4.3997. If you join those 2 points, again we will get the next false position as 1.8592. For more clarity, let us zoom here and see. the secant line joining B and D passes through the marked point 1.85920. So now this is your new false position. You can also see that these values are actually coming closer to the actual root. Next step, we can see that 1.8592 is again negative and f of 3 is positive. That means the value lies between these two numbers. So we will continue the process like this. So now x3 is 2.0021, which is the intersection of the secant line with the x-axis. Let us continue the process. We can find in each step, we can find x4, x5, x6, the same method, and at some stage you can stop our calculation by taking the root as 2.0816. Now let us discuss the general procedure of Regula-Falsi. Let f of x be a continuous function. The first step what you have to do is you have to find two numbers a and b such that f of a times f of b is less than 0. That is, both of them are of opposite sign. Then next step, we will consider the secant line whose equation is y minus f of a divided by x minus a, which is equal to f of b minus f of a divided by b minus a. Let this secant line cut the x-axis at the point xr, x equal to xr. So how to find this point x equal to xr? We have to put y equal to 0 in the equation of step 2. Basic calculation will help you in finding xr as a f of b minus b f of a divided by f of b minus f of a. Now here there are three cases. Case 1, if f of xr is equal to 0, that means xr is the root of the equation and we will stop the process here. If not, f of a times f of xr is negative will imply that the root lies between a and xr. So we will replace b with xr in step 1 and proceed. In case 3, if f of xr times f of b is less than 0, we will replace a with xr in step 1 and proceed. So this process will continue until we reach the interval length less than a given epsilon. Now let us see some problems.